Hello class and welcome to today's topic. It's about area under the normal curve. So in our previous meeting we discussed the normal distribution and some properties of the normal distribution. So we know that the normal distribution is a bell-shaped curve with mean mu. It has two parameters, the mean or mu and the standard deviation or sigma. And the area under the normal distribution is 1. So today we are going to discuss the area or how to calculate the area under the normal curve. All right, so as I mentioned, the total area under the normal curve equals 1. So the area under the curve represents the probability and proportion. Also, you can think about the percent of observations. All right, so we know the normal distribution. Now, different normal distributions have different means, right? And different standard deviations. So we may have like a normal distribution with mean 10 and standard deviation of 5. Another normal distribution with mean of 2 and sigma of 20. Right? So for normal distribution, we could have any value for mu and any positive value for sigma. Now, to simplify probabilities, we convert all normal distributions into one common distribution or a standard distribution. So this common distribution is called standard normal distribution. So a standard normal distribution is a special case of the normal distribution when the mean equals 0 and the standard deviation equals 1. Again, it's a special case of the normal distribution. The mean is 0 and the standard deviation equals 1. So we call it a standard normal distribution. And all Z tables are based on this standard normal distribution. And we use the letter Z. So for example, for normal distribution, for example, if X follows a normal distribution with mean 10 and the standard deviation 5, what we say X follows N. N means a standard normal distribution with mean, let's say 10 and the standard deviation of 5, right? Now, if we have a standard normal distribution, so we call it Z, follows N01. All right, so X is the normal distribution. If we have a standard normal distribution, we give it a name, we call it Z, all right? Z follows normal distribution 0 and 1, which means follows a standard normal distribution. All right, now, as I mentioned, any normal distribution can be converted to a standard normal distribution to get 0, mean, and standard deviation 1. So to do that, we have to use the Z-score. All right, so Z-score, which is given by X minus mu divided by sigma, is used to convert the normal distribution to a standard normal distribution. All right, now the value of Z or the value of Z-score tells us how many standard deviation we are from the mean. Okay, for example, Z equals 1 means we are 1 standard deviation from the mean. So let me explain here. Suppose this is our standard normal distribution, and which means the mean is 0. And the standard deviation is 1. So let's say this is 1, this is 2, this is 3 sigmas, this is -1, -2, -3, right? And this is the value of Z. So Z equals 1 means we are here. We are 1 standard deviation from the mean. Z equals 2 means we are 2 standard deviation from the mean. Z equals -1 means we are 1 standard deviation below the mean. So when z is negative, this means we are below the mean in this area. When z is positive, this means we are above the mean, which is this area here. All right, so what does the z table show? So the standard normal distribution table, or we call it the z table, gives the area to the left of the z-score. Okay? For example, what is probability that or below z equals negative 2.17? All right, so we are going to find the probability or the area below negative 2.17. So what we do, we have to locate negative 2.1 on the left column, right? Locate negative 2.1 in the left column. So as you see, negative 2.1 is here, right? And then we have to move across to the column with 0.07. So if you go in this way, go to the right. So here you see this value, right? So this is, the column is 0.07. So probability z less than, so let me write here, probability z less than negative 2.17 equals, this is negative 2.1, right? Move to the right until you reach the column 0.07. So probability z less than negative 2.17 equals 0.015, which means it's about 1.5%. So this is how we find the area or the probability under the standard normal distribution. So we have two tables, one for the negative values of z, as you see here. The left column is negative, so we have negative values of z. It gives you the area to the left of the number. And also, in the next slide, we are going to see the other table for positive values of z. So remember, this standard normal distribution or z table gives us the area below the number. It gives us the area below. Now, if I ask you a question like, or if we have a question like, what is probability z is greater than negative 2.17? For example, here, what is probability z is greater than negative 2.17? Now, to answer this question, we have to think about the complement rule. Because again, the table gives us the area below. This is the area above. So we know the fact that the area or the entire probability or the entire area under the standard normal distribution equals 1, right? So the area above negative 2.17 equals 1 minus probability z less than negative 2.17. So you can say less than or equal, doesn't matter because this is a continuous distribution. All right, so the area above equals 1 minus the area below, and the area below from the table is 1 minus 0.015. So the answer is 0.985. So this is the area above negative 2.17. And as you see here, negative 2.17 is here. So as you see, it's very large probability. So it's about 98.5%. But the area below negative 2.17 is a small area here, right? Okay. All right, so now I'm going to erase this because I need to go to the next slide. Next, we are going to discuss another example. What is the probability that z is less than 1.23? Okay, so this value of z is positive, so we have to look at the positive z table or the positive normal distribution table. So as you see here in the left column, we have positive values of z. So to answer this question, you have, very similar to what we did in the previous slide, you have to locate 1.2 in the left column, right? And then you have to move across to the first decimal place, which is 0.03 column, and the intersection gives us the probability below 1.23. So the answer is 89.07%. So this is the total area or the total probability below the number. Next, we have an example. The example says IQ scores are normally distributed with mean equals 100 and the standard deviation equals 15. The first question, what is the probability that a person's IQ is greater than 110? All right, so this is a normal distribution, not a standard normal distribution. So we have to find the z-score of 110. All right, so we have to find probability that x, not z. We are dealing now with a standard normal distribution, right? We have to find probability x is greater than 110. Now, first we have to find the z-score of 110. So the z equals x minus mu divided by sigma. So x is 110. The mean is 100 divided by sigma, which is 15. So 10 divided by 15, or 0.67 if you round to 2 decimal places, right? So probability x is greater than 110 is equivalent to probability that z is greater than 0.67. So this is a normal distribution. This is a standard normal distribution, and they are equivalent, right? And to find this probability, remember the standard normal distribution gives us the area below the number. This is the area above. Okay, so what we do, we use the fact that the total probability is 1. So the area above equals 1 minus probability z less than 0.67. All right, and we have to find this probability from the table. So if we go to the previous slide, we have to look for 0.67. 0.67 means you have to look at the column where this is 0.6, right? We have 0.6, and then move across to the column with 0.07. So if you go to the right with that column, so the probability should be 0.715. I'm sorry, it's 1 minus that. It's 1 minus that probability. Actually, not 7486, right? 7486. So the answer is about 0.2514. So this is the probability below, or the probability below z equals 0.67. All right, so again, this is how we calculate any probability. If we have a standard normal distribution, which means mu 0 and sigma is 1, then we can find the probability directly from the table. If we have a normal distribution, you have to convert it to a standard normal distribution by finding the z-score first, And then once we have a standard normal distribution, we can use the z-table to find the probability. All right, so let's move to the second part. The second part is, what is the probability that a person's IQ is between 85 and 115? Similarly, we have to find probability z or x is between 85 and 115. So we have to find the z-score of each number. We have to find the z-score of 85 and the z-score of 115. So let me call it z1 and z2. z1 equals x, which is 85, minus 100 minus a mu divided by sigma. Sigma is 15. So it's negative 15 divided by 15, it's negative 1. This is z1. Similarly, z2 equals 115 minus 100 divided by 15 is 1. So this question is equivalent to probability z is between negative 1 and 1. All right, now how can we find this probability? We know how to find the area above a number or area below a number, but how can we find the area in between? So let me explain, make small graph here. We have to find the area between negative 1 and 1. Let's say negative 1 is here, 1 is here. We have to find this probability. Right? Now, this probability is equivalent to the following. The area below 1, the entire area or the entire probability below 1 minus the area below negative 1. Okay, so again, the area in the middle is the area below 1 because it gives you everything, all of the probability below 1. Take away the probability or the area below negative 1. So once you subtract, you get the area in between. So here, what we do, we have to do the following. So this equals probability z is less than 1 minus probability z less than negative 1. All right, and then we can use the standard normal distribution table to find each probability. All right, so if we go back to the previous slide, because it has the table, probability z is less than 1 is here, right? This is 1. So it's 0.8413 minus, if you go to the previous, to the first slide where we have the negative z-score, then the area below negative 1, it should be 0.1587. All right, so it's not written in this slide because this is, I just cut part of the table. But if you look at the actual z-score, you have to scroll down and look for z equals negative 1 to the left. So the value is not written in this table because this is like screenshot of that. So once you subtract, so the answer is 0.6828. All right, so the area is about 68.3%. All right, so this is the idea of calculating the probability under any normal distribution. So the key idea is to find the z-score. If your distribution is a normal distribution, you have to convert it to a standard normal distribution first by finding the z-score, and then you can find the area below the number from the table. If the question is about the area above the number, we use the complement rule. It's 1 minus the area below. If the question is about the area between two numbers, then we calculate the area below the large number, take away the area below the small number, then we get the area in between. All right, thank you very much for watching.